I'm Anil Kumar, and in this video, we'll consider basic concepts about normal form of equation of line. So let me take few examples first, and then we'll discuss what is written here. So let me draw a few lines. The lines could be in quadrant 1, 2, 3, or 4. So I'll make 4 different sketches depending on in which quadrant the line is. And then we'll see how to write equation of a line when it is given to us, right? So that's the whole concept. So let me just make the axis so that I could draw lines in different quadrants. So here's the first line, which is in quadrant 1, which goes through the quadrant 1, I should say. And then we'll draw a line here which has x and y intercepts corresponding to quadrant 2. And then we can have a line which could be somewhere here, right? Kind of like this. Or we could have a line which is kind of like this. I'm not considering special cases here, means a horizontal line and the lines through the origin, right? There are reasons for that, which we will discuss. Okay. So if we are given a line like this, then from the origin, we can always draw a perpendicular to the line. Let's say this is the perpendicular to the line from the origin. Oh. In that case, it is possible to write equation of this line in terms of P, the perpendicular distance, and omega, the angle which the perpendicular makes with positive x-axis, right? So it is possible to write an equation, and this equation normally is called the normal form of the equation. It is written as x cos omega plus y sin omega. And of course, for such a situation, you need length of perpendicular, so we are taking that to be greater than 0, and the angle omega is measured from the positive x-axis counterclockwise. It could be from 0 to 360 degrees, right? So I hope you can correlate now this equation, x cos omega plus y sin omega equals to P, where P is the length of perpendicular. Perpendicular is treated as normal to the line from origin, and omega is angle which normal makes with the positive direction of x-axis. Correct? So you can actually pause the video, sketch normals, right, from the origin to the line in different cases, right? So for example, these are the normals. All these normals will make 90 degrees angle with the line, correct? Now, can you tell me what is omega in each case? What is omega? The angle which positive x-axis makes with the normal. So in this case, you'll see that omega is more than 90 degrees. And here, it is more than 180 degrees. And in this case, it is more than 270 degrees, right? So these could be 4 different positions of omega, saying that omega is between 0 to 360 degrees. In each case, we can always have length of the perpendicular drawn from origin, P. And once we know omega, the angle which x-axis makes with the line is perpendicular, normal, then we can always write this equation in the form given to us, right? So that is the basic concept, and these are 4 basic situations given to you. Let's move on and take some examples based on this. Now the question here is, find equation of a line whose perpendicular distance P from origin is 5 units and the angle which normal makes with positive x direction is 30 degrees. So in this particular case, if I want to sketch the diagram, we are given that the normal makes an angle of 30 degrees. So let's make the normal first. It makes an angle of 30 degrees. So that is the normal. We are not sketching the line first. 30 degrees. Find equation of line whose perpendicular length P from origin is 5. This length is given to us as 5 from the origin. Do you see that? What should the line be? So to sketch the line, what we can do is we can draw a line which is perpendicular to our normal, right? So somehow, let's say something like this. Do you see that? So that is how you could actually construct your line. You get it? Where this angle, which the normal makes with the line, is 90 degrees. Correct? What angle will the line make? Find this angle. Now, this angle is sum of 90 and 30. External angle, 120 degrees. The line makes 120 degrees. Anyway, the equation of the line, let me call this line as L. So the equation of the line L will be given in terms of perpendicular distance and this angle, which normal makes with the positive x-axis, as x cos omega is 30 degrees plus y sine 30 degrees equals to P. We are so used to seeing lines in standard form, so you could actually take a calculator, find what cos 30 degrees is. You could also use special triangles in this case. Cos 30 degrees square root 3. So I could also write this as x times square root 3 over 2 plus y times, you could do sine 30, is half. But it's better to calculate, so it's half equals to 5. Do you see that? So you could write this in standard form also as square root 3 over 2x plus half y equals to 5. And normally in standard form we don't try to avoid this fractions. So multiplying each by 2, we get square root 3 x plus y equals to 10. You could also bring them together and then write square root 3x plus y minus 10 equals to 0. And that becomes the standard form. Do you see that? So that is a familiar equation. You could have converted this into any form you like, right? So the idea is that we could represent a line in normal form, and then from there we could also write it in other forms. So let me take another example. This time the equation is find equation of line whose distance from the origin is 5 units and the angle which line makes with positive x direction is 120. Now here we are not giving you angle with the normal. We say the angle which the line makes with the positive x axis, correct? So let's try to sketch this case. Okay, so it says find equation line whose distance from origin is 5 units. So when I say distance from origin is 5 units, that means that this length is fixed. This length, which is perpendicular to this, right? Anyway, let's think like this. Let me draw which line makes positive axis 180. Let me sketch the line first so that it makes 120 degrees angle. So let's say this is my line, and line makes an angle of, means this angle this time is given to us as 120 degrees. Do you see that? The angle which line makes is 120 degrees. That really means the angle which the normal will make, will be 30 degrees, correct? And it says the normal is 5 units away, so that is length will be 5 units, correct? So that is one scenario. However, in this particular case, we may have another scenario. That is to say, we could also have a line which could make 120 degrees with the positive x-axis, and it could be like this. So that could also be a situation. Do you see that? So both are possible situations for us. In this particular case, the line still makes 120 degrees with the positive x-axis, right? So sometimes with a given description, you have to be very careful as to see where the line is, right? So with the given information, what we can say is it could be either of these positions, and what we are given is that the distance is 5 units. These drawings are not to the scale, they're just to explain the concept. So of course in this particular case, you know that since the angle is 90 degrees, I could have written this equation as x cos 30 degrees plus y sine 30 degrees equals to the distance 5. In this particular case, as you can see, the angle is not 30 degrees, correct? The angle is not 30 degrees. It is this angle, correct? That is omega. That is the angle in this particular case. Now here, since we have 120 degrees, that means here the angle should be 60 degrees. And since that is 90, we are looking for an angle which is 180 plus 30 degrees. We are looking for 180 plus 30 degrees, which is 210 degrees. So in this particular case, the equation will be x cos 210 degrees plus y sine 210 degrees equals to 5. So if you are given angle which line makes with the positive x direction, in that case, as you can see, there could be two cases. We could say case 1 and case 2. Correct? So if I write the equation, cos of 120 degrees, cos 120 degrees is minus half. So here what you get is minus half x. Cos is negative here, right? Okay, and sine of 210, both are negative. Sine 210 equals to minus half. What did I do? Cos 210. This is wrong. Cos 210 is square root 3 over 2. Yeah, now it's correct. And we have minus half y equals to 5. Correct? So what you see here is that when we're kind of in quadrant 3, in that case, both these values are negative. Do you see that? So a line could make 120 degrees, but we could get two different situations. So at times, we may need additional information to be very precise as which is the right case. Now, if you write equation in the normal form, you could always translate it into any other form. For example, here, this time, let me work with this second equation. If I divide by 5, both the values, what do I get? I get from here minus square root 3 over 10 x minus 1 over 10 y equals to 1. Or so we get intercepts from here. If you could write this in intercept form. So let me just write this equation in intercept form. I could write it as x over this. We have minus 10 over square root 3, right, plus y over minus, so when we are just reciprocating it, right, so bringing this here minus 10, right, over 1, you can say, equals to 1. And that gives you x and y intercepts. So that means this point here is minus 10. And the other point there is minus 10 over square root 3. You get the idea. So it's very easy to work with equation normal form. You can translate them into standard form, intercept form, find intercepts, and also find slopes, right? You could write this in slope and intercept form and find slopes. So let's take another example here. Now we have find equation of a line whose perpendicular distance p from origin is 10 units and the angle which the normal makes with the positive x direction is 135. So let's sketch this first. 135 is in quadrant 2. So if I make an angle of 135, let this be the angle. Let me draw a line which will be the normal, right? So this is the normal, correct? So because we want 10 units away, since we want 10 units away, so we could draw a line perpendicular, let's say like this, so that this distance here is 10, correct? The angle given to us 135 degrees. Now we can write down the equation of the line in normal form, right? This is 90 degrees. So we can write down this equation as x cos of 135 degrees plus y sine of 135 degrees is equal to length of the perpendicular, which is 10, right? Now let's see how we can use this equation. Cos of 135. Cos 135 is, so we write minus square root 2 over 2x, and sine is positive. Now the sine 135 is square root 2 over 2. Y equals to 10. From this equation also, you can make out that x-intercept is negative and the y-intercept is positive, as you can see. We can find the slope. Slope finding, rearrange this in y equals to mx plus b form. So bringing it to the right gives us square root 2 over 2y equals to square root 2 over 2x plus 10. So y is equal to square root 2 over 2x times 2 over square root 2 dividing by this plus 10 times 2 over square root 2, right? So that gives you the equation as y equals to, and that is 1, that is x. And then here we have, we could write this as 5 plus, so that goes square root 2 times 10 square root 2. Is that okay? So we can get slope of the line is 1, right? Slope of the line is 1, since the angle is 135, so that makes this angle is 45 degrees, and slope of the line is 1. So anyway, we're trying to test how to write equation normal form and then convert it into different forms and get familiarized with known equations which are standard form, intercept form, and slope intercept forms. So I hope with these three examples you got an idea of using normal form of the lines. It is always easy to find equation in normal form when we are given distance from origin to the line, which is p, and the angle which the normal makes with positive x-axis. I hope that's helpful. Thanks for watching and all the best.